The stars work hard at creating matter. Matter that forms the earth and all life on it. Over the last 2 billion years, life has evolved and adapted to its surroundings. We began walking on 2 feet, freeing up our hands that will eventually shape the world as we know it today. We discovered the way to shape stone, to create sharp edges and make crude tools, paving the Stone Age. This simple ability to modify stone opens up thousands of new possibilities and the ability to reach new food sources in other regions of the world despite the varied conditions unique to our planet. We discover fire and learn to tame it. Fire is now used to cook food. The change in diet leads to the development of a bigger brain, a giant leap in cranial capacity, allowing our ancestors to have cognitive abilities. We begin to form complex sounds, ultimately leading to the development of language. Language helps us communicate, identify food sources, and build dependable social structures. Permanent settlements appear, and small communities begin to farm and domesticate animals. The first cities appear on the fertile plains near rivers. Cereals are introduced as a supplementary source of nutrition. As we advance, we begin to build structures and monuments to commemorate our progress. We invent the wheel and discover that the animals we have tamed can move us faster, cover large distances, leading to some great journeys, bringing various races together. Our ancient metallurgists start mixing and blending metals, and the Bronze Age is born. We use bronze to develop sharper tools and stronger weapons, leading to large conflicts. These disputes for territory and struggle for power restrict supply of materials, forcing us to look for alternates. Iron leads to further advancements in weapons and tools, and the Iron Age is born. The continued fight for power sees the rise and fall of empires, beliefs, religions, and trade networks. Our quest leads us to coal, and suddenly a new way to power lives emerges. The steam engine begins the Industrial Revolution, and just like that, the world is transformed from an agrarian economy to one characterized by mechanization. We invent the far more efficient internal combustion engine, one that generates far more power by burning high-calorie fuel and air. Soon, the first automobile is born, forever changing the way the world moves. Oil becomes the most important commodity on the planet. The physical world begins to shrink with aircrafts, ships, and trains moving people and cargo across the globe. We humans march on, and space becomes a new frontier to explore and occupy. Powered machinery leads to technological and economic progress on a scale never witnessed before. Refinements in semiconductor technology result in the first integrated circuit leading to the electronics age. The first computer is born, and the processing of information has taken a quantum leap. Cell phones arrive, connecting people across the globe, leading to unprecedented development. The internet is next, and all of a sudden we have the World Wide Web. Doing business on a global scale becomes efficient, and the tech revolution produces a significant rise in consumption. Information is available faster than ever, and the use of information technology is all pervasive. The ever-expanding internet, along with software and application, enables collaboration, and the world can now become one integrated community. The ability to transform and functionalize materials is necessary for realizing a sustainable future at a time of climate change and global warming. The creation of a self-cleaning smart processor brings in the next IC revolution, intelligent compounding. The smart processor, with its game-changing fractional lobe geometry, provides the necessary capability for development of a new generation of materials. The novel fractional elements, NFE, replaces conventional kneading blocks, completely removing pressure peaks and providing shear uniformity. There are no perpendicular faces to the melt flow, unlike the conventional kneading blocks, with these fractional lobe novel elements, and therefore no stagnation to the flow. We can now imagine that a great number of applications with sensitive materials can succeed. Existing applications can be made more effective and efficient. Our advanced processes and platform technologies change the way medicines are made. The pharmaceutical industry faces a dire need to move from batch to continuous processes in order to safeguard from regulatory stricture disrupting the business. By using a self-contained, self-cleaning vessel that can transform the bulk material properties in a single step during a very short time interval, we are addressing the most pressing need of the industry in making optimized granules towards preparing the final dosage form. The manufacturing overheads, footprint, and the number of processing steps are vastly reduced, bringing in long-term sustainability and overall equipment effectiveness. There is greater energy efficiency and negligible waste management, leading to a greener process. We follow the Six Sigma framework and process analytics to develop these specific solutions, and therefore it is possible to effectively optimize the scale-up and ensure long-term process stability and control from R&D stage to plant stage in a structured and smooth manner.
At STEERLife, with an unique and seamless blend of engineering and pharmaceutical expertise, we are committed to the design and creation of advanced technologies capable of revolutionizing the way the world makes and takes medicines. Our expertise in technologies and R&D processes will transform the way medicines are currently manufactured. That is, moving from batch to continuous, and thereby moving from quality by testing to quality by design. It's time to change.
Without a telescope, we cannot have astronomy. Without a microscope, we cannot understand biology. With this smart processor, we have just opened up a whole new world of opportunities for growth and progress in materials technology. Together, we can co-create a bright future.